ihasmath, and you're going to learn how to find the equation of a parabola from its graph. We are going to use everything from the earlier videos for this, so if you haven't watched those yet, stop this one for now and catch up first. I'm going to show you three methods, one based on the vector form of the equation, one based on the factorized form, and one using the calculator. Let's get right into it. As a quick recap, here are the two forms of quadratic equations we know already. In the vertex form, B and C represent a shift of the vertex from the origin, while A represents the stretch factor vertically. In the factorized form, A is still a stretch factor, but P and Q represent the x-intercepts. Keep in mind that positive numbers in the bracket lead to negative x-intercept and vice versa. Which form of the equation should you choose? Well, that will depend on whether you can easily read off the vertex or the x-intercepts. In the example on the left, it's easy to read off the vertex, but not the x-intercepts, so the vertex form is the way to go. While in the example on the right, you can't easily read off the vertex, but the x-intercepts are okay, so you would use the factorized form. If you can read off both the vertex and the x-intercepts, I suggest you go with the vertex form, because this makes some follow-up questions easier later on. In these two examples, there was no vertical stretch nor a reflection, but we should always keep in mind that these can occur. Let's look at an example of this. In this case, the vertex can easily be found at 2, 5, but the x-intercepts can't be clearly read off. Vertex form it is, and I pop 2 for B and 5 for C into the equation. This is a pretty sad parabola, and I can see that starting from the vertex, I can clearly read off a point going 1 to the right and 2 down, instead of the normal 1 up. This means there must be a negative 2 in the equation, and the equation is y is equal to negative 2 times x minus 2 in brackets squared plus 5. Easy. Next example. In this case, I can't read off the vertex, but I can see the x-intercepts at 3 and negative 6. Pop these into the equation. Now I'm in a bit of a pickle. Because I can't clearly identify the vertex, I can't do my thing going 1 across and stepping up. But here is the thing. We've got an equation that connects x and y and only has one more variable in it. We can substitute in the coordinates of a point and solve for a. I can identify a number of points on the graph, but I want to keep the numbers simple. So the y-intercept is a good choice. So negative 6 is equal to a times negative 3 times 6. Simplify. Divide by 18 to get the a by itself, and simplify the fraction using your calculator. A is 1/3 and the equation is y is equal to 1/3 times by brackets x minus 3 times by brackets x plus 6. This is a good way for finding a, and it always works as long as you can read off one extra point. Note that you can't use one of the x-intercepts because that would just leave you with an equation 0 equals 0, and that doesn't really tell you anything about a. One more example. Why don't you try this one yourself? Pause the video and give it a go. I'm clearly going with the vertex form here, so I substitute 3 for B and 5 for C into the equation. I can't use my method going 1 across and then stepping up or down because that point can't be read off properly. But I'm not going to panic. I'm looking for the coordinates of a point to substitute in, but that y-intercept looks a bit fishy. Instead I'm using 1, 2 and solve for a. So 2 is equal to a times 1 minus 3 in brackets squared plus 5. Simplify, take away 5 from both sides, then divide by 4, and a is equal to negative 3/4. That's about as hard as it gets. If you tried it yourself, you may have fallen for the fake y-intercept at negative 2. The real one is actually at negative 1.75, but really impossible to read off properly from the graph. Be absolutely certain that the coordinates you substitute are actually on the graph. Before you go, I want to quickly show you an alternative method that works for all of these parabolas. It uses the regression function on your graphics calculator. It's based on giving the calculator a number of coordinates of points, and it then comes up with an equation. Let's have another look at this last example. I can easily read off a number of points, but you need to be sure. Don't fall to close calls. I want to use 4 of them. 1, 2, 3, 5, 5, 2, and 7, negative 7. Make sure you don't miss out on the negative signs. In the calculator, I go to Menu, 2 for Stat, that is Statistics, copy these points into the table. The x values into list 1 and the y values into list 2. If you already have values in these lists, delete them first. Confirm each entry with the exit button and use the D-pad to move around in the table. Then press F2 for calc to calculate, F3 for rec, which is regression, and finally f3 for x squared for a parabola. The output is a bit confusing at first. On the bottom you can see what the numbers a, b, c mean. They are the coefficients of the x squared, the x, and the constant term without an x at the end. And the equation is y is equal to negative 0.75x squared plus 4.5x minus 1.75, which is correct, but it's neither the vertex nor the factorized form, so it's going to be harder for other people to draw this. When you do this, always check the r squared value. It's not part of the equation, but if it's anything but 1, the 4 points you've entered don't lie on the parabola and you've actually made a mistake. Use this for checking that you've done it correctly. There is a lot going on here and it will take a lot of practice. However, there's nothing else to it. When you've mastered these skills, you can write down the equation of any parabola that you may encounter. Finally, you should really learn all these methods, with the calculator method as the new plan B. It's fine to use, but because it doesn't give you the equation of the parabola in vertex form, you may find it harder to answer some follow-up questions. Basically, if you can't find the equation any other way, use the calculator.